Hello everyone, my name is Pranjal and I am from Team Synapse. And the problem that we are trying to solve is to address the communication gap between deaf and non-deaf communities, especially in Southeast Asia, particularly India. So South Asia, particularly India, is home to a large portion of the global deaf population that is estimated to be around 60 million as such. And the lack of accessibility and communication tool poses a large challenge for education and employment of such deaf community. The government is trying to establish Indian Sign Language as an official language, and there is a need of innovative solutions to bridge the communication gap. In order to solve this problem, we have put forward our approach is to build a real-time sign language recognition model based on the Indian Sign Language dataset. So for that we have used basically two approaches. First is the LSTM model, uh, and the second is using state-of-the-art vision transformer models. Now let us look at the dataset that we have used. So the dataset that we have used in our training is the include dataset that has around 4,200 videos, and it was recorded in St. Louis School in Chennai. And for our prototype, as of now, we have included 8 categories, which include 79 videos in train, 14 in test, and 11 in validation. And for our prototype, the categories that we have trained on are these categories. Now, for the first model, that is the LSTM model, the pre-processing stage consists of these steps. First is passing the loop to from the camera feed to the OpenCP processing. Then we are using Google's media pipe model to extract the key points from each frame, and these key points are saved into an NP array and passed on to the model. And for the transformer model, we have segregated into 3 sets: train, test, and validation. And then we have done some sampling on the videos, that is setting the clip duration and using uniform sampling. After that, we have applied some transformations like frame selection, normalization, random resizing, random cropping, random horizontal flip. These transformations we have applied after various experiments. And after that, the model selection for the transformer model, that the model that we have chosen is a video MAE model that was proposed in this paper, and it has claimed state-of-the-art performance on several video classification benchmarks. For that, we have tested with several fine-tuning techniques such as Q load up, PEFT, and head and backbone fine-tuning. And for this prototype, we found that the fine-tuning the head and backbone of the model was successful in our case. So we have run the model in 3 different stages. In first run, we fine-tuned the linear scheduler with constant decay for initial training, but it was not as much successful, for which we moved forward to run 2. In second run, we did a hyperparameter grid search to find the optimal hyperparameters, and in run 3, we did some some configurations with LR scheduler, and we obtained some better results. Now the evaluation metrics that we have looked upon are accuracy, precision, F1 score, loss. So for our prototype, the final metrics that we have received are F1 score of 0.9, precision of 0.8, recall of 0.91, accuracy of 0.91, and loss of 0.3. So the F1 score in the first run, he received an F1 score of around 0.47. In the second run, it was a bit unstable due to the Marmot ratio and LR scheduler not managing itself. Hence, but still we received LR of F1 of 0.62. In the third run, it was a more better. It gave us better result of around 0.91. Similarly, for accuracy, in the first run for 50th step we ran it and we got 0.45. In the second run, it was a bit unstable, but after third run we got an accuracy of 0.90. And similarly for the loss, the first run, second run, and the third run, final loss we got around 0.3. And the precision also similarly, after the third run we got precision of 0.86. The alert schedulers that we used during the 3 run are: first run we used linear decay, in second run we used linear scheduler, and for the third run we used reduce LR on plateau along with an initial warm up that we uh, found out after some experiments. In the next stage, we will show a demo on our teammates local computer that has around 4 GBs of GPU, and later on we will provide hosted interface for after the whole complete training is done, and the code can be found out in this GitHub repo. Thank you from my side.
So good evening. So today I'll be giving you a demo for the model that we have built. So let us take a look at the data. So the given video here denotes the ISL sign for happy. So let us see the output. As you can see, the model predicts the class correctly as happy. This is the data for ISL sign language for blind. So let us see the output. We get the correct predicted class, which is blind.